All right, we're looking at right now just the homework that was due today, and so as you're watching this at home, you can also just check your answers against these. In the first 15 here, most people generally get those right because you can just see them on the unit circle. So if you'll just look at those quickly and carefully. We're going to slide down to the ones at the bottom of the page. And the ones that I would have you pay close attention to would be number 23 and number 24 there, to see that you got the right thing here. When you did number 23 on your calculator, you should have gotten 4e to the negative 13. And like we talked about in class last time, that anytime you get the exponent to be a negative number like it is here, that should indicate that they're trying to tell us that the answer is 0. All right, and then on 24, when we do the cotangent of 4 pi, you get negative 5e to the 12th. All right, now, because of that negative sign, we would be inclined to think that perhaps that's negative infinity, but we want to just put infinity there, because this would be a place where, when we're looking at the graph of this, as it gets close to there, on one side it's coming down like this, and on the other side it's like that. And so we'd have a hard time telling which one of those, whether it should be negative infinity or positive infinity, because it would depend on whether we were looking from the left or looking from the right. So in these two, I want you to check carefully on your paper to make sure you get those right. All right, does anybody in class have a question about those? Okay, undefined or infinity would come to the same thing, because the way we get infinity is a 1 divided by 0 type thing, so the division would be undefined. So if you say undefined instead of infinity, that's fine. Okay, when you put number 24 in your calculator, you're going to get negative 5e to the 12th. And anytime we get an e with a power bigger than 10, then basically what it's doing is we've got something like 0 getting divided into something here. And so what we had said in class last time is we would say that's undefined. All right, so a lot of people here, you know, like if it was just 1 divided by 0, they would just say it goes infinitely many times, and so that's why I'd put the infinitely many, but undefined is a better answer. Okay, now, would you check carefully on your 26, 27, 28, and 29, and I have these answers rounded to hundreds. It's okay with me if you have them rounded to thousandths, or if you have them rounded to tenths, either one. All right. In 26 and 27, there's really not a whole lot that we had to do, because remember that since we have a tangent key, here we can just go x equals, and we'll just put tangent inverse of 0.75. And that's going to give us the answer that we have here. Now, one of the things you got to be careful about, you got to make sure that you're in degree mode, so that it gives you the answer in decimal degrees. If you're not in degree mode, it would give you the corresponding radian value, which is probably about 1 point something. Okay. All right. Yes, Baxter. All right, I'll get to that one. All right. Okay, in 26 and 27 are that sort of same thing. Now, in 28, 29, and 30, all right, so in 28, since this is secant, and we don't have a secant key on the calculator, then we've got to replace secant with what secant's equal to, which is 1 over cosine. And then, if we take the reciprocal on both sides, we're just going to turn this upside down, then I'm going to get cosine here. And then here, this was 1.84 over 1. If I turn that upside down, I get 1 over 1.84. Then I do the same kind of thing I would have done in 27. I would go cosine inverse of 1 over 1.84, and then it should give me the quantity that I have here, which will give me that answer. Okay. Now 29 and 30 are done similarly to what 28 was. It's just with cotangent, since there's no cotangent key, you've got to use the fact that cotangent is 1 over tangent. And then here cosecant in number 30 is 1 over sine. And so you can see the work that's here to get those. Anybody have a question about those? Okay. All right. Let's look at this slide. Yes, ma'am. Okay. All right. Let me know when you've had enough time to check those. While everybody's checking that, just a reminder down that the test is Friday. Make sure that you spend some time on Thursday looking back at stuff. All right, has everybody had enough time to check this now? All right. Sydney, you're good. All right. All right. We covered part of this in class last time. I'm going to go ahead and just start with it again. Last year in your Algebra 2 class in Miss Jones's room, you talked enough about converting from radians to degrees and vice versa, but the first skill that we're going to talk about is converting from radians to degrees. Basically, if you look on the unit circle over at the point where I just marked here, in degrees, that's 180 degrees, but it's also pi radians. And so we know that there is a sense in which these two are equivalent. And so we can say that degrees is to radians as 180 is to pi. And then we can take this equation and cross multiply. And when we cross multiply, we're going to get d times pi equals 180r. And since, let's see, 180r, and since we want to solve this equation for d this time to get degrees when we're given radians, then we'd get that the number of degrees is 180 divided by pi times r. And so the way I have it written here, I have the r first because you'll be given the radian measure and you'll just multiply by 180. All right, and we had done a few problems right at the end of class last time. So I'm going to redo this one, and I'm going to talk about this one for a minute. So on this one, if we're going to change this angle from radians to degrees, this is 3 pi over 5 radians. So we're going to multiply by 180 over pi. The pi's cancel. All right, and now I know you can use your calculator to simplify these expressions, but almost always the denominator number here is going to divide into that, and it's something you can do in your head with a little bit of practice. And then here you would get 36 times 3, so that's 108 degrees. So 3 pi over 5 is 108 degrees. All right, if we look at this one, notice that in this one, this is 6 radians. There is no pi associated with it. And so when we multiply this time by the 180 over pi, then we're going to get on top, I believe that's 1,080, and on the bottom we'll get pi. So the correct answer to this then is 1,080 over pi degrees. And that's the kind of answer you'd be expected to give on a test, as opposed to dividing that out on your calculator and giving some decimal value of roughly 300 or so, 300 and something. All right, now the second skill is going the other way and converting from degrees to radians. And so if we take the same equation that we had here to start with, and then once we had cross multiplied like before, where we had d pi equals 180r, if we want to solve this one for r, we're going to divide by 180 on both sides. And so you can see here that the r is equal to pi over 180 times d. All right, and so I have it written this way because what happens for most people is if I give you something like 60 degrees and you want to convert that to radians, you're just going to put the pi there, the 180 here. You're going to reduce this and get pi over 3. All right, everybody okay with that? Okay, all right. If you just take the number of degrees, so that would be 60, and you're just going to multiply it by pi over 180. And that will convert it to radians. Mm-hmm. And so 60 degrees is pi over 3 radians. Now, one of the things that a lot of people do for the numbers between 0 and 360 is, since you have a unit circle, you just look on the unit circle, and it'll have the 60 degrees, and it'll have the pi over 3 written there a lot of times. Okay? All right, now, would you practice real quick with these problems? Just convert those to radians. The first one you could actually use the unit circle for. On the others, you have to use the formula that we were talking about. In this first one, it turns out that 135 is divisible by 45, and so is 180. And so 45 into 135 is 3, and 45 into 180 is 4. So this is going to be 3 pi over 4. Now, something that you can do on your calculator for this, let me get the calculator turned on, is you can get the calculator if you have access to it. Now, on the test day, you won't have access to it, but when you're doing homework problems, you will. I'll show you how to get the calculator to do that. It's something you probably know, but it's something that might have been old by the time you started using a graphing calculator, and you might have inadvertently not been taught it. All right, what we can do here is we're starting with 135 degrees, and we know we're going to divide by 180. So if we just do divide by 180 and then go math 1, then that gives that as a reduced fraction, and we can just write the pi beside it. Now, I think you probably knew how to do that, but just in case, it's good to get that where it's demonstrated once. Okay, now we could actually do the exact same thing we just did there on these other problems, because here, if we're going to multiply this by pi over 180, let me have you do some reducing for me here. When you look at that and you're just going to reduce it, think 4th grade, 5th grade, whatever, what's the first thing you do about reducing it? All right. All right. Several people there said just cancel off the zeros at the end. That makes it an easy thing. All right. And now we'll start looking to see if it's divisible by 2 or by 3 or whatever. Right. Now this is divisible by 6. 18 is divisible by 6. Is 84 divisible by 6 without a remainder? No. All right. Yes. How many times does 6 go into 84? All right, 14. Okay, so if we divide by 6 here, we get 3. If we divide by 6 here, we get 14. And so we have this one being 14 pi over 3. All right, let's do the negative 235. Now on this one, I don't think it's going to be very pretty. Tell me a number that'll divide into both of them. All right, 5. Okay, so we get a 36 here. And if we divide by 5 here, we're going to get a 47. Is that right? All right. And now 47 is a prime number. And so the answer to this then is just going to be negative 47 pi over 36. All right. I don't know how many times in your mathematical life you'll actually wind up doing this particular kind of thing, but it is a skill that's taught to everybody that ever takes a trig class, and so it's one that you should know. All right, what we're going to start talking about next is there is a formula to find the length of an arc. All right, and so the formula is going to be this thing right here. All right, now and it's going to reduce just a little bit. So um, let me talk our way through this thing for a minute. Remember that in geometry, when you had a central angle, the measure of the arc was equal to the measure of the central angle, but the measure of this arc then was given in degrees. All right, and what we want to do is we want to get this just in radians, which are real numbers. For example, if this was a large circle and you were going to go for a walk, you might be interested in knowing that you walked 100 degrees, but you'd probably, if it was a large circle, you'd be more interested in knowing I walked a quarter of a mile. You'd want it as a distance. And so we're going to get a formula in just a minute that's going to give that as a distance. All right, and so one of the things that you ought to be able to see to begin with is this, that if I want to get the measure of that arc, that it's going to be related to the circumference of the circle. And so this part of the formula right here is just the circumference. All right, and then do you see that this fraction right here represents the fractional part of the circle that the arc is? In other words, all the way around in a circle would be 360 degrees. Well, if I just have here, say, 110 degrees, then I would have 110 over 360. That would be the fractional part of the circumference that I'm going. And so we'd take that fractional part of the circumference and multiply it by 2 pi r. Now, there's some things that you learned in geometry that will simplify this a little bit, and that's what we're going to find out here. So let's look here. All right, if you remember from geometry, the measure of a central angle is equal to the measure of the intercepted arc. So that theta is the same as that in degrees. All right, we want the theta to be measured in radians so that we can get the arc here in radians. All right, and so we know that theta then is going to be the measure of the arc in degrees multiplied by pi over 180. All right, and so if we take that equation right there and we solve it for the measure of arc AB, then we get that the measure of arc AB is theta times 180 over pi. Now, in case that's anywhere near hard to see, if I want to solve for this and I've got it times this, remember I just have to multiply by the reciprocal of that. And so if I multiply by that reciprocal, then over here we got 180 over pi times theta, which is what that's saying here. All right, now, what that's going to do is that's going to allow us to put this expression here back where that measure of arc AB was in this equation right here. So if we take that equation and then we put the theta times 180 over pi in for it, then we can do some fancy stuff here. This theta will cancel that, or I said this theta, this pi will cancel that pi. That 2 will cancel this 360 and be 180. Now what I've got left up here is 180, and that's 180. So those 180s are going to cancel. And so once we do all that canceling, we're left with S equals theta times R. So what we get here is this is the arc length, and then this is theta measured in radians, and that's the radius. Now, this formula is going to be important in a bunch of the work that we're going to do today, and I'm going to give you a worksheet that's going to have a chart on it, and in class we're going to do some problems that are similar to that, and then in the homework you'll be expected to fill in those. Now, this little part right here is probably the thing that's newest to you out of all the stuff we're doing, because I think you know from your Algebra 2 class the other formula. I'm not sure you know this one. You may. Did y'all learn this formula last year? All right, so heads are shaking no. Okay, so now the big deal to this one is you got to remember there that theta is the measure of the central angle in radians. All right, I get my money back or my points back on the test from you if you forget that it's measured in radians and you put degrees, because there's no part credit if you do that. All right, so let's look at this for a minute. We're going to do some problems with this. So let's try this one for a minute. Let's say that this angle is 100 degrees, and let's say that R is 8 inches. Okay, and so if I want to find this distance, then the first thing I'm going to need to do is I'm going to need to convert theta to radians. Baxter. All right, it is, but that doesn't mean I have to give it to you in radians. If I give it to you in degrees, you have to convert it. That's why we have to learn those other formulas. Okay, so if we have the 100 degrees, then what do I do to convert degrees to radians? What do I multiply by? All right, the pi over 180. All right, so if we do our reducing here, we can cancel those zeros, and then 2 goes into each of these. And so theta measured in radians is 5 pi over 9. Now, the question would be, I wrote the R here, and it would be, do you have to write theta in radians there? You don't. You just have to put the number 5 pi over 9 in. So if I want to get the length of the arc, if I plug into this formula, S equals theta times R, then I'm going to get 5 pi over 9 multiplied by 8, and then I get this rather unenlightened looking answer of 40 pi over 9. All right, now, the unit that goes on this answer will be the unit that's on the other length in the problem. So since this is in inches, then we would get that this is 40 pi over 9 inches. All right, is your question about that one? Okay. All right, now, what I have here is a little chart, and in doing these 5 problems, we will cover most of the things that you'll ever see with this. So notice that in the chart, here's the S, so that's the arc length. The R is the radius. Here's theta in radians, and here's theta in degrees. Now, the reason we have both of these columns is that in easy problems, they give us the theta in radians, like in this first one, but then in other problems, they give you the theta in degrees, like the example we just did, and you have to do more work. So, in this first problem, if I just look at this formula right here, am I just allowed to plug these 2 numbers in and multiply and get the number that goes here? All right, and everybody's saying yes. Okay, so all we're going to do here is we're going to say pi over 3 times 21. We're canceling, and we're going to get 7 pi. What's the unit on this 7 pi? All right, it is in inches, all right, because this is a unit of length, and so we have to use the measure that's here. Now, just to say that we have filled in everything, I also will want you to convert that to degrees. What's pi over 3 in degrees? All right, it's 60. Okay, now, again, I saw some of you looking for your unit circle, which is a smart thing to do. You can just look on the unit circle to see that. Now, suppose your unit circle got burned, the dog ate it, just something where you don't have a unit circle there. What do you do to pi over 3 to get that 60? And it's one of the skills we learned. All right, we multiply it by 180 over pi. The pi's will cancel, and then 180 divided by 3 is 60. All right. Now, if I give an answer for an angle that is in degrees, I have to write the degree sign. If I don't write the degree sign, it's understood to be radians. Now, there are some textbooks that you will see that every time they mean for it to be radians, will put a little R there. All right. That's not something that everybody does. And so what you have to learn is, if I do not see a degree sign, it's automatically radians. The books that put the little R there are just trying to make sure that they're saying to the students, hey, this is in radians, so be careful. Well, we don't need somebody to tell us to be careful. We should be able to do that anyway. Okay, so now I'm going to refer to this one as number 1. So now we're on number 2. Let me erase what we've got up here because we need to put work. What's the first thing we would need to do in this problem if we were given the 16 feet and the 135 degrees? Peyton? All right, because we need to convert to degrees, right? All right, and so this is one we did earlier. 45 goes into that 3 times, and 45 goes into that 4 times, so this is 3 pi over 4. All right, Peyton, fill in the rest of this formula then. If we're going to get S, what happens here? And our answer would be, all right, 12 pi. I'm going to write it here. And what will our unit be? All right. And it's feet because the radius was measured in feet. All right. In the next one's similar to what we just did. This is probably the most common case, and that's why I put two of them in here. What's 240 degrees in radians? So 240 multiplied by, all right, it's going to be 4/3 pi. All right. All right, now, when we do 4/3 pi times 18, all right, so here's 18 times 4/3 pi. All right, it is going to be 24 pi, okay? And our unit's going to be, all right, yards. Now, notice that as long as we get radian values right here, we're going to get something that has a pi in it right here. Well, I said that wrong. When we have our radian values, if there's a pi occurring in the radian value, there'll be a pi occurring right here. All right. Now, would you do number 4? And we'll give you just about 10 seconds to sort of get started on it. Some of you might be done in 10 seconds. But it's just the given is different. What's the difference this time? All right, we have to find the r. So normally in the problems we'd been given theta and r and had to find s. Well, here we're given s and theta. So we could go here 24 pi equals, and we'd put in the 5 pi over 4 here, and then get r. All right, help me through this. How do I get the answer now? How do I solve for r? What do I multiply by? All right, we want to multiply by that reciprocal, so we're going to multiply by 4 over 5 pi. All right, and so over here, rather than write, it's just going to be an r. So over here, the pi's cancel. All right, 5 doesn't go into any of that, so we're just going to multiply, so it's going to be 96 over 5. All right. Now, we have some options here. We can write that as 96 over 5 inches, and if you did, I'd count that right. We can divide the 5 into that, and I believe that's going to be 19.2. Somebody check that on the calculator. But I think that's right. And so we could then write it like that, if you prefer. And, and this will be on the part of the test where you don't have your calculator, so you might be inclined to write the 96.5 there. But when you're just doing the homework and you have your calculator, you probably would write that as the 19.2. Now, just to finish the chart, what's 5 pi over 4 in radians? How much? All right, 225. All right, it's 225 degrees. All right, now, in this last one, notice that we're given degree measure and we're given theta. So on that last one, what's the first thing that has to happen? All right, we have to convert the 60 degrees to radians. So Peyton, how many radians is 60 degrees? All right, pi over 3. Okay, now if we take our numbers here, we've got a 6 pi here, and we've got pi over 3. And then we've got, that's our r. All right, so we're going to multiply by 3 over pi. And so it just looks like 18, right? Is that what you got? All right, so 18 yards. Now, on the sheet that I'm giving you for homework tonight, there is one of these that has a fairly strange answer, and so on it, I've got the answer written on the solutions key for you in several different ways. If you use your calculator, you can round it to a decimal, but I'd like an exact answer if you can get it. But it's a sort of strange exact answer, but it's the very last homework problem on this. Okay. Now, the next thing that we're going to do is we're going to go over uh, how to fill in the values on a unit circle. So at the beginning of class, I gave out to you this little sheet that says for practice only. And so you just have this so you didn't have to write it in. I did give that to you, right? Okay. All right. If you'll take that out, we're going to talk about what you're going to have to do on the quiz. Now, your quiz is going to be on Tuesday of next week. And if you see any of the people that are not here today, they're going to be responsible for that quiz because they'll be able to see this by then as well. All right. Now, you will be given a sheet that looks just like this, except it won't say for practice only, and you basically just have to fill it in. Okay, and so I'm going to talk to you about the way I do this. Now, Miss Jones has her way of doing it also, and I don't remember her way. I just remember that it's a good way. So if you happen to remember her way and prefer it over the way that I'm going to show you, that's fine. All right. Now, on the inside here, I want you to write these in radian measure instead of degree measure. Okay? All right, so now, when we're going to write this in radian measure, the way I look at this is this. Remember up here at the top, it's pi over 2, so you get a 2 occurring in that fraction. All right, and then down here at the very bottom, there's a 2 that's going to occur in that fraction. This is 3 pi over 2. All right, now, the closer that you go towards the middle of the circle, the bigger the denominator gets. Now, that may seem like a stupid way of thinking something, but this will be a 3, this will be a 4, and this one is a 6 there. Now, first of all, this is 0. We need to put in that that's 0. You also need to put in that the 1 here is pi. Okay? But now, you've got 2, 3, 4, 6. All right? Now, if we go over here in this quadrant, it's the same way. This is going to have a 3 in the denominator. This is going to have a 4. This is going to have a 6. All right? Now, in the first quadrant, if you look at that, do you see that every numerator is just pi? So it's just like the number is a 1 and there's a pi beside it. So we get these just like that. Now, in every quadrant, there's going to be something that tells you the number that goes with the pi. All right? What's the pattern in the second quadrant? If you just look at your unit circle. All right? Say it again, Emily. All right. All right. Emily said that the numerator will be the number in the denominator minus 1, and then you get a pi. Okay, so since this is a 3, this will be 2 pi. Since this is a 4, this will be 3 pi. Since this is a 6, that will be 5 pi. Now, that's correct. Okay, now let's work down here in the third quadrant. All right, remember that the farther we go from the bottom or the top, the bigger the number becomes. So this is the fraction that goes with this one. This is the fraction that goes here. This is the fraction that goes with this one. Okay, so this is going to have a 3, a 4, and a 6 in it. Now, what's true about the numerators in the third quadrant? All right, it's the denominator plus 1. So this will be 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2. Now, notice on that 3 pi over 2, 3 pi over 2 is really not in the third quadrant, but it's not in the fourth quadrant either, but it behaves according to the rule for each of them. So if you think of it as being, okay, I could just use the rule for the third quadrant, it gives you the right answer. Okay, now over in the fourth quadrant, this is a 3, this is a 4, this is a 6. Okay, now, what's the rule for the numerator here? All right, you can just memorize, but there's actually a rule. All right, it's the denominator times 2 minus 1. That's a good catch. All right, so if I do this denominator times 2, that'll be 6, minus 1 is 5. Denominator times 2 is 8, minus 1 is 7. Denominator times 2 is 12, minus 1 is 11. All right, so that's the first part. Okay, now for the second part, I want us to put in the sign values in the first quadrant. Okay, now here's the way I'm going to tell you to remember the sign. It's going to be the square root of n over 2, where n equals 0, 1, 2, 3, 4. Now, that may sound stupid, but once you see what I mean by this, you can get this right. If I put a 0 up on top here, do you see this becomes 0 over 2, which is 0? So if I'm starting here, that one's going to be a 0. All right, now, if I put a 1 in there, square root of 1 is 1, so this becomes 1/2, which is what the sign is here. If I put a 2 in there, it becomes square root of 2 over 2, which is what it is at pi over 4. And then if I put a 3 in, it becomes square root of 3 over 2 here, which is what it is at pi over 3. And then if I put a 4 in, the square root of 4 is 2, and 2 over 2 is 1, and so you get those numbers. Now, I know that's not quite what Miss Jones does with it, all right, but it's a way to get the numbers. Okay, now, if you're going to get the cosine, you take these numbers and write them starting here. So it's 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. All right. From my point of view, if you can get those numbers in the first quadrant right, then you can get everything else right based on the symmetry in the circle. Okay? Because right here, do you see that these 2 points, I'm going to draw something in green here for a second, that these 2 points are on the same horizontal line? That means their y coordinates are the same, right? All right, so right here, I'm going to get a square root of 3 over 2. All right? And then if I come straight across on this one, I'm going to get the same y coordinate, so that's the square root of 2 over 2. Then this will be a 1/2, and this will be a 0. So you could think of it like this. Every time I get up to 1, I've got to come back down to 0, and I'm just running off. That's those same numbers that I wrote over here in the first quadrant. Now, over here on the x values, this point right here is as far to the left of the origin as this point right here, the one right there, is to the right of it. And so that just means that the number it goes for x here is the opposite of the number that's there. So this is negative root 3 over 2 here. This is negative root 2 over 2 here. And this is negative 1/2 there. Okay? Does it make sense that way at all? Right, because you can do it differently. But I think Miss Jones draws some triangles to start with, right, to get you to see things. Or does something similar. I think it's with triangles. She does squares, okay? And both ways work, and work fairly quickly. But on this one, I'm so used to doing this that I can, if I have to think of what's going on down here, I just have to think of what the pattern is to get it. And truthfully, I've done it so long, I do sort of visualize it. Okay, now, there's another thing going on here that I just want to point out just briefly. Remember, in the first quadrant, both signs are positive. In the second quadrant, the x-coordinate's negative and the y-coordinate's positive. In the third quadrant, both signs are negative, and in the fourth quadrant, it goes positive, negative. Okay, so I know when I'm in the third quadrant, I'm going to put a negative on everything, but look over in the second quadrant for a minute. Do you see how on the x's it's going 0, negative 1/2, negative square root 2 over 2, negative square root 3 over 3, negative 1? Now, it's got to go back down towards 0, so it's going to be the same numbers in that same order. And part of that logic is this point right here is directly below that one. So since it is, they're going to have the same x coordinate, so this is negative square root of 3 over 2. But now, once you get with a start here, remember, if you have a 1 and then a square root of 3 over 2, you're going to get a square root of 2 over 2. You're going to get a 1/2. We just have to remember they're negative, and then here we get a 0. Okay, now we can use the same kind of logic here. Um, this the the y coordinate here. This point is as far below the x-axis as this point is above it, and so therefore this is negative a half, and then this will be negative root 2 over 2 for the same kind of logic, negative root 3 over 2. How many of you think something like this? Because I know you've done this before, so when you're trying to think of how you're going to get it, you do associations. How many of you think every time you got a square root of 3 over 2, you always have a 1/2 with it? The only one where you have the same thing is when you got square root of 2 over 2, right? Okay, and so if you keep that in mind, and you can get either one of the x's or the y's to be right, you can get the other one by just remembering, if I've got a 1/2, I get a square root of 3 over 2, and then depending on the quadrant, I've got to get the signs right. Okay, so now this one's negative 1, and through similar logic, we can do the same stuff. So right here, this is 0, so I know this will be a half, this will be square root of 2 over 2, this will be square root of 3 over 2, and that's a 1. All right, that's a 0, and there's a negative 1 here, so this will be a negative a half, a negative root 2 over 2, a negative root 3 over 2, and the negative 1. Okay, now that gets all the ordered pairs. Okay, now the last thing that we have to do is we have to get the tangent values on the outside. All right, so with the tangent values, one of the things that I think of is this. You get zeros, you get square root of 3 over 3s, you get 1, you get square root of 3s. And then you get that it's undefined, and when it's undefined, I'm going to put the infinity symbol just to be putting it. Or you can write undefined if you prefer that. But anyway, these are the values we're going to get. And if you'll think about that, this is increasing order of size. The square root of 3 over 3 is less than 1 because 3 is bigger than its square root. Square root of 3 is bigger than 1. All right, so over here, the way you know to get this is you divide the y coordinate by the x coordinate. Okay, so this would be 0. All right, if I divide the 1/2 by the square root of 3 over 2, I'm just going to do this 1, and then I'm going to tell you the pattern that I've got does the rest of it. If you do this square root of 3 over 2, remember you invert the bottom one, so it becomes the top one times the bottom one inverted. The 2's cancel, so this is 1 over the square root of 3. And then when you rationalize that, we're doing all this work here, but we wind up with square root of 3 over 3. Okay, so once you see that done one time, the fun's gone, so it's better to just, most people just want to memorize that. This is 1. It's a number over itself. On this one, the 2's on the bottom cancel, so it's square root of 3 over 1. All right, and then right here, this is positive infinity or undefined. Now, I'm going to write undefined because technically that's what it is. A lot of people, though, will put the infinity symbol here. Okay, now, in the second quadrant, we're going to have here a positive divided by a negative, so our answer is going to be negative. All right, anytime that we get down to where it's either infinity or undefined, then we go back through these numbers going the other way. In other words, here, the 2's will cancel. It's going to be square root of 3 over negative 1, so this is negative square root of 3. All right, the next one will be negative 1. The next one will be negative square root of 3 over 3. This will be 0. All right, now, this will continue. In the third quadrant, you've got a negative divided by a negative, which will be positive, so we're going to get these numbers working back up this way. So we're going to, that's 0. This will be square root of 3 over 3. This will be 1. This will be square root of 3. This will be undefined. All right, now, when this one's undefined, if you just think of the first one to get it right here, the 2's cancel, so it's negative square root of 3 over 1. And you know if you're at the negative square root of 3 and you just had the undefined, then we're basically going this way again. So this will be negative 1, negative root 3 over 3. So you've got to be able to fill all of that in. Okay, now, if you'll think about that, there are 64 numbers that you have to put in there because there's 16 radian values you put on the inside, and then for every radian value you got to have an x, a y, and a tangent. So it's 16 times 4. So there's 64 things you put in there. When you take that quiz on Tuesday, if you don't make 100 on it, you have to either come back before school or after school to do a retake. But I mentioned the other day, you want to make sure that on all these little quizzes I give you that you get hundreds on them, because it sort of pads your grade a little bit, because there is one chapter that's very hard for a lot of people, and if you want to make an A, you want to really kill this chapter with a great grade and then make something close to an A on the hard test when we get to the hard test. That's in chapter 6. Okay, now tonight's assignment is to finish the worksheet that I'm going to give to you in a minute, but because we have time left and we're running behind because of J-term, I'm going to start the next thing. So there's going to be a pause on this, and I'm going to give you the next stuff. You may. Now, on the homework sheet there, remind me to give that to you before you leave. I don't want to give it to you now because I don't want you working on it while we start doing the same stuff. Okay? Now, I've got, I think I have the first. I do find this sheet that I'm giving you now, but the sheet that I'm giving you now is one you need to put in your notebook that you've got, and because it's not all short fast. I admire people that struggle to do that. All right, we're back. Now, I need to tell everybody that just received packets about the stuff that you got, and those of you who are listening to the tape, some of you received the packets the other day. The rest of you will get them when you come back to class. All right. The first packet that I want you to look at is the one that just has the blank axes on it. All right. When we do practice problems here in the next few minutes, you want to do the problems on those axes. All right. And so that's going to be important because it just gives you a place that you can do that. All right. There was a sheet that I gave you, and it says things to know when graphing trig functions. All right. That one you need to hole punch and just put in your notebook, because we'll be on this particular section for the rest of today, and then we'll be on it Tuesday after we take the test on Friday for a while. and there will be a certain part of the work that you're going to be required to do tonight, and then the other part you will do next time. So anyway, those are the two things that you got in addition to your packet. So I need to get that up here. One of the difficulties with recording the lesson is because I have this thing around my head. I'm thinking more about what I am saying on the recording than I am thinking of things to say to you all. And for one of the things it does is it keeps me more on task, where I'm less likely to tell a story or less likely to do something spontaneous, because it's really bad when you can't see the spontaneous thing and you're just listening to this. All right, now I have this sheet on here just to remind me to give the quiz at the beginning of the class, and so since we're going to be starting here, we'll just have that quiz obviously next time. All right, so and those are the answers to the things you're going to get. So right here, this is the sheet that I gave you that's going to turn out to be really important. And so I'm going to start by just talking about some things here, and you can take the notes on your note packet as opposed to the sheet where this is written on it. It would probably be the best thing. All right, what we're going to do in this lesson is we're going to graph sinusoids. All right, now, a sinusoid is a trig curve. I don't know why that happened. Let's see if I can get it back. Okay. All right, but a graph that looks like this is a sinusoid. All right, now, when you have a sinusoid, whether it's a sine curve or a cosine curve, basically there's going to be a line that goes through the middle of the graph. And I'm going to refer to that as the midline of the graph. If there is no vertical shift in the graph, that will always be on the x-axis. But when this number d here is not 0, then there will be a vertical shift, and so that'll change. All right, and then you may remember that a sine curve is periodic. All right, and the period is the length that it takes to go from where the sine curve is 0 and starting up to where it's 0 and starting up again. So that distance right there is the period of the sinusoid. And again, whether it's a sine curve or a cosine curve, that same basic principle is at work. All right, and so the distance that you go above the midline is the amplitude. And so each of these phrases that we have here are going to be important phrases to us. And then we're going to start graphing problems that will just have like the A involved in it. And then we'll do ones that have A and B involved in it. And then we'll have A, B, and C. And then we will have A, B, C, and D. Now, here's what I'd like for you to think of. Each of the numbers A, B, C, and D that occur there are going to control something about the shape of the sinusoid. All right? And so on this first one, since the amplitude is the absolute value of the number A, that's going to tell us how far above and how far below the midline that it goes. All right, now, what I'd like to do is I would like to go to this slide and start talking to you, because I've got stuff written in here that you won't have to copy. But we talked about the number one here about what it means for a function to be periodic. When we say that a sine function is periodic, that means that they repeat their shape over an interval. Now, here's a way I like to think of this. I want you to think of it like if I have that, and then I repeat it here, and then I repeat it again, it would be like having a camera that takes this picture, and then the camera takes the exact same picture again, and then the camera takes the exact same picture again to where all the pictures would look alike. Now, because I'm freehanding, they don't look alike there, but if you can get that minimum distance that will make all the pictures look alike, that's the period. Okay? All right? Now, in a period of a sine curve, there are going to be 5 key points. There's going to be the point where the graph crosses the x-axis, the point where it gets its maximum height, where it crosses the x-axis again, where it gets its minimum height, and then where it gets back to the x-axis again. And the good news about these is those 5 points are spaced equally on the x-axis there. And so, since the distance I just marked off here is the period, if I take the period and divide it by 4, that will tell me the distance between the key points. So these 5 points I will refer to as being the key points. And every time that we graph a sinusoid, we have to get the 5 key points in the right place. And as long as we do that, then basically we're going to be doing things correctly. There are a few little things that we'll learn when we get to the more complicated ones that I'll add to that. But that's the basic part in which we're going to start. All right, now, so here's just the basic 2 functions again, and I start here by saying the things I just said to you about each of the letters A, B, and C, and D control something that pertains to the shape of the graph. All right, the A controls the amplitude or the height of the curve above the midline, and the amplitude is defined to be the absolute value of A. All right, now, we're going to graph some problems that are going to fit like this. So you're going to graph each one of these on a different one of those little grids that I gave you. I gave you enough grids that we could graph all of these. All right, so let's look at this first one. All right, if we have y equals 4 sine x, one of the things I want you to do is to write on your paper that the amplitude is equal to 4, because we just take the absolute value of the number. All right, now, if there is no number in front of that x or below it, you know, if there's no fraction occurring, then the period is going to be 2 pi. So the first thing that we're going to do is we're going to mark where 0 is. We're going to pick a distance, and we're going to call that distance 2 pi, and then we're going to divide this into 4 equal parts. So you want to get the midpoint of it, and then you want to get the midpoint of each of those 2, and then this will be pi over 2, this will be pi, this will be 3 pi over 2. Now, on the y-axis, we need to put a 4 and a negative 4. Now, in some problems, you're going to want to keep a relative scale. And what I mean by a relative scale is you want a unit on x to be about as big as a unit on y. Now, think about this for a minute. Do you see that right here where that pi is, we're saying that this distance right here is basically 3.14. Okay, so now if I want to keep a relative scale here, then I want to go a little bit further than that distance up this way and put the 4, and then about the same distance down here and put negative 4. Okay, now I want to erase this little part right here because I don't want the graph to look ugly. So this is pi over 2. All right, now the way you will be graded on information, you will be graded on getting the scale on the x-axis right, you'll be graded on getting the scale on the y-axis right, and then you'll be graded on getting the 5 key points in the right place, and then there'll be one other thing that I'll tell you about in just a second. All right, now, for problems like this one, getting the 5 numbers that go on the x-axis are easy. You just take the period, which was 2 pi, and you divide it by 4, and you count them by that number. So this would reduce to pi over 2. Now, I want to hear you count by pi over 2s after I do it one time. So it's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So if you count by pi over 2s, it's just one of them, then 2 of them, then 3 of them. And so if I'm writing this down, 1 pi over 2, I would write as pi over 2. 2 pi over 2, I would just simplify to pi. 3 pi over 2, and then this would be 4 pi over 2 right here, which would be 2 pi. Okay, so if you just count by this thing that you got when you took the period and divided it by 4, then if you just count by that number, you get everything right. Now, because this is a sine curve, we know that the period's going to begin at 0 here. All right. Now, on a sine curve, if the number that's right here is positive, does the graph go up first or does it go down first? All right, it goes up. All right, and so we know that at pi over 2, we're going to get a point here. At pi, we're going to get a point here. Then we're going to get the point that's down here. Then we're going to get the point that's there. Okay, now, once you put those 5 points on your paper, you remember first grade and you play dot to dot. All right, now, when you draw this, we will not draw something that looks like straight lines. All right, it's a curve. All right, and so one good way to get some kind of shape to the curve is you want to come here and then just aim towards this one. All right, and then go like that. All right, and it's the same idea. You make a little bit of curve down towards the end is what it looks like. And then we go like that. Now, once you get that part done, the graph does not stop when we get to 2 pi. So you always want to draw through that and put an arrow to indicate it keeps going. You want to do this and put an arrow to indicate that it keeps going. So the thing I told you I was going to tell you later is make sure you put the arrow on it to indicate that it keeps going. All right, so one of the things that you have to do in the homework and then on the next test is to be able to graph simple sinusoids. Now, we're also going to graph complicated ones. We're just going to build it up. Everybody good with that? Okay. Now, do you remember doing this last year? And basically, you did the same thing, right? Okay. All right. Now, let me erase this. Because I think you know what you're doing, I'm going to go faster than we're going now until we get to some that might be challenging. All right. So look at this one. What's the period this time? All right, the period is going to be 2 pi. All right, and so you always take the period and divide by 4, and that tells you how far apart the key points are. All right, when there is no number in front of that x, the period's automatically 2 pi. And then when we get a number, I'll show you how you find it. Okay, so we're going to count by pi over 2's. So I'm going to make 4 tick marks. Now, I showed you one way to do it last time, and if you want to continue to do it that way, it's fine. In other words, just pick your distance to be 2 pi, bisect it, and then bisect each of those. All right, or you can just do it like I did this time. Just pick a distance, mark that distance off. All right, now I'm going to do the count by pi over 2's. So this is 1 pi over 2. Then this is 2 pi over 2. Now if I write 2 pi over 2, that just simplifies to pi. This is 3 pi over 2. This is 4 pi over 2. And that simplifies to 2 pi. So that's got the x scale. Now, what are the numbers that need to go on the y? All right, 3 and -3. Okay, now, this time, I did not make any deliberate attempt to keep my scale relative, though it actually appears to be a decent one, because this distance appears to be a bit more than that one, and pi is just a little bit bigger than 3. Okay, now, we know it starts here. Let's see, there's something I didn't have you right. What's the amplitude? All right, the amplitude is 3, because remember the amplitude is the absolute value of the number that's in front. Now, because this is negative, though, what does that do to the graph? All right, it means we go down first. Several of you are indicating that. So we're here, so we're going to get our lowest point at this one. We're going to be back to 0 here. We're going to be up at the highest point here. We're going to be back to 0 here. So when we draw this, now first of all, it's going to continue going, so I'm going to have that arrow. I'm going to draw that, make it come through this, round it a little bit there, make it go like that, and draw the arrow. Right. Questions, comments? Nothing particularly hard so far, right? Okay, now, let's do this one. What if we have 5 cosine? Now, obviously, the big deal difference here is we got cosine this time. All right. What's the basic difference between a cosine curve and a sine curve? Okay, all right. Several people just said it starts at the top of the curve. In other words, the highest point on the curve is going to be on the y-axis. Okay, so here, our amplitude is still 5. Our period is still going to be 2 pi. Okay, so I'm going to lay off that x-axis first. Since it's going to be what we had before, I'm not going to give a big explanation. This is just pi over 2, pi, 3 pi over 2, and 2 pi. All right, now we're going to put the 5 and the negative 5 here. Okay, now, based on what y'all told me, you said it starts at the high point at 0. All right, so we get a point here. Where's it going to be at pi over 2 then? All right, it's 0, and at pi it's going to be at negative 5. All right, at 3 pi over 2 it's back to 0. At 2 pi it's back to the top. Okay, now, when we draw this one, one thing that's a little bit different than the others. All right, I'm going to start here at this point, and I'm going to go this way. Okay, now, because this doesn't stop, you're going to round that and make it come back down. All right, what would be wrong with me doing this? If the point's here, and I've got it doing here, and then I have it going there. Yeah, it doesn't continue up. All right, you're getting to a place bigger than 5. So you got to make sure you draw this coming back down and put your little arrow. All right, and then here we're coming down to here, back up to here, back up to there. We come past it, draw the arrow going back down. Well, the sign never ends up at the top like that. So when we were doing the sign ones, remember they would always end at a point like this. So we'd do this, and then we wouldn't stop here. We'd go past and draw an arrow. But the arrow was not up at the top of the curve or at the bottom of the curve in those cases. Okay, now let's go to the next thing. All right, in what we're going to look at here, we're going to have the A that's going to be the amplitude, and this time we're going to have a number that's in front of the X. Okay, and so the absolute value of the A will still be the amplitude. All right, but the period of the sine or cosine function is going to be this. It's 2 pi divided by the absolute value of B. Now, you may never see a B that is negative. I mean, I don't know if we'll have one this year on it, but a lot of times in calculus, we don't actually do so much graphing as we do just taking a derivative kind of thing. But the B value is rarely negative. But to be technically correct, that has to have an absolute value sign on it there. Okay, so now we're going to do this little set of problems. So here's the first one. All right, now the amplitude is going to be 3, just like before. So I'm going to have us, let's see, let me move some stuff down. I'm going to put a 3 and a negative 3 just from that, because nothing about that's changing. Now, to get the period, we're going to go 2 pi, and we're going to divide it by the B. So our B here is 2. So this time, the period is going to be pi. So the period is pi. All right. Now, if you look on the sheet that I gave you, let me pull it up here so everybody that's needing to watch the video can see it. But let's see. All right, so this page right here. In Roman numeral 2 here, it says a graph of a trig function should contain a correctly scaled x and y axis. We've done enough for you to understand that. It has to contain the 5 key points, all right? And then the graph also has to it has to intersect the y-axis. We haven't done any that didn't yet. When we do one of those, I'll come back and mention that. But now, in number 3, The period divided by 4 is going to be the distance between those tick marks. And I just wanted you to see where that was written at right there. All right, so now let's go back to where we were and deal with that. Okay, so if I take the period here and divide it by 4, that tells me the distance between the tick marks. So when I start writing out tick marks here, then this is pi over 4. And so if I count by pi over 4s, it's 1 pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4, and that will get the x-axis scale correctly. All right, now it's a sine curve, so where do we start? All right, at 0. All right, do we go up or down first for this particular one? All right, we go up first. And so once we know that, we're sort of a victim of what we've done, but in a good sense of being the victim. Our work makes it where it's easy to finish it. And we want to make sure that we put the arrows at the end. Okay, any question about that? Now, what happens with these is I try to go up incrementally so that you can see different things. So right here, what I want you to see is that we don't always have those same old numbers on the x-axis. They're different here than what they were when the period was different. All right, now let's take this one. All right, now put that up there. So our amplitude is 4. All right, now to get the period, we're going to do 2 pi divided by, and what's our b value here? The b value. All right, the b value is 2/3, okay, because this is 2/3 x. All right, so we're doing 2 pi divided by 2/3, so that becomes 2 pi times 3 over 2, and so the period is 3 pi. All right, now, to get how far apart the tick marks are, we've got to take the period and divide it by 4. So this time we're basically counting by 3 pi over 4s. All right, so I'm going to write that this is 3 pi over 4, and then 2 times 3 pi over 4 will be 6 pi over 4, which is 3 pi over 2. 3 times 3 pi over 4 will be 9 pi over 4. 4 times 3 pi over 4 will be 3 pi. All right, and then we're going to go up 4, and we're going to go down 4. Now, I don't have a really good relative scale here, but remember that 3 pi is about 10 units long. Let's see, let me make my y's a little bit better because of that. If it's about 10 units long, then probably something like this is probably a reasonable scale. All right, now we're dealing with a cosine function this time. So tell me what happens. All right, it starts at the top. All right, since it starts at the top, we're going to remember to draw the little part coming down. All right, and then it's going to go here. It's going to be down at -4 here. It's going to be 0 here. It's going to be back up to the top here. All right, and now we'll just complete that. Okay. All right. Any questions on that one? All right, we're going to do one more, and then I'm going to stop. I'm going to talk to you about the classes you register for next year as far as the math stuff. I talked to... But it's... Have I already done that?
No.
Has it been done in other classes, though?
No, it hasn't.
Oh, you get nervous. Oh, about the classes for next year. All right. Well, I can relieve your stress. Okay. Let's get this one first, though. All right. Now, what's our amplitude? All right. Let's see. What's our amplitude? All right. The amplitude's the absolute value, so it's 2. All right. Now, to get the period, we've got to do 2 pi divided by the b number, so it's 2 pi over 3. All right. Now, if I divide this by 4, dividing by 4 is the same as multiplying by 1/4. So I'm going to get 2 pi over 12, which will be pi over 6. So I'm going to count by pi over 6 here. So this is pi over 6. 2 pi over 6 would be pi over 3. 3 pi over 6 would be pi over 2. 4 pi over 6 would be 2 pi over 3. So notice that all of a sudden those numbers on X get a little bit different. All right, now we've got to go up 2 and down 2. All right, and it is a sine curve, so we're starting at 0, but we're going down first, right, because it's negative. So it's going here, back to 0, up to 1, back to there. All right, so we're here. Like that. Okay? All right, now I'm going to pause again for a second because I need to check something. Okay, the assignment for next time is to complete the first worksheet that you can pick up that has the box in it. That's about the radian measure. And then on the second worksheet, I want you to do 1 to 5 and 11. So this is going to be on a homework packet that's got graphing trig functions. So I just want you to do that part of it and that's due on Tuesday. And we'll go over that after we take the quiz. Now, let me talk to you about, you can give them out, yeah. All right, now, let me talk to you about the classes that you have the chance to register for and how that goes. Now, I actually pre-registered, when I say pre-registered, I gave the teacher approvals in yesterday. And so when you have your conference with the guidance counselor, then the guidance counselor can help you pick the correct one. So now I'm going to start from the bottom end and sort of work up for a minute. All right. If you have a grade that's C or lower at the end of the first semester, then automatically the only course that I can recommend you for is the honors probability and statistics. Okay. Now, there are a few of you who have a semester grade of something like 83. All right. And one person in particular, they made a bad exam grade and it pulled it down to a C when normally they would have had a B. All right. Well, if you have a C right now, but you get the grade average up to a B by the end of the semester, then you can get changed into AP Stats, which is a good option. Okay. AP Stat is a better course than the honors version of it simply because you get the college credit. Now, this course is not an exceptionally hard course, and it's something that anybody who's in pre-cal should be able to pass next year, but most of you want something that looks good on your application to go to college, and so if you get the B and get into AP Stat, it's better. All right. Now, having said that part about this, I need to sort of work down from the top end of the scale. All right. There are 3 courses that you qualify for if you have a B or above. All right. One of them is AP Calc BC. All right. In AP Calc BC, the disadvantage to it, in your eyes, is it meets every day. All right. The advantage to it, though, is you get 6 semester hours of college credit for it. All right. The reason you want to take this one, if you qualify for it, is that usually the people who teach calculus in high school are among the better teachers that the high school has in the math department. All right. In college, calculus is the low rung on the ladder, and so it's usually taught by a graduate student who is working on a PhD in mathematics. Now, first of all, there's not that many people who work on PhDs in mathematics. Most of the people who really go for the PhD in mathematics are either Chinese, Indian, Russian, Pakistani, etc. And so their native language is not English. Okay, and just about everybody that goes to Carolina or State or any of the places like that, and that takes just a regular calc course and then has to get into one that's taught by a grad student, they will tell you that the biggest problem is that it's hard to understand the person simply because their native tongue is not English. And when you ask them a question, then they don't always handle questions as well because, again, their native tongue is not English. It's not that they're not smart. It's just that they have a problem here. You do not. Let me talk about that for a second, all right? If you're going to do anything that relates to anything that's mathematical, anything that's in the sciences, if you want to be a doctor, believe it or not, you have to take calculus. All right. If you want to go like into, pre-med, or any of those. All right. If you're going to major in business, it would help to take calculus. Now, when you go to college, they will have a business calculus class, but you'll understand that business calculus a whole lot better if you take calculus. All right, because in the calculus class in both of the calculus classes that we have here, the book that we use is a good book, and it has some business situations in it, but the problems in the book that we use are excellent problems for just the kind of things that you can encounter with calculus. But let's see. Let me go on with this. But if you're a person who is I don't know if I'll ever do it, it's sometimes better to be safe and do it, and just you learn calculus but you didn't need it, than it is to go the other way. All right. Now, there's AP Calc AB, all right, and it's 3 semester hours, and it meets every other day. All right. Now, if what we do is this: if a person has a 93 or above at the semester in Precal, we recommend you for this course. Okay. Now, if you have an 89 or higher and you want to be in that course, you can be in the course. All you have to do is make an appeal, and we'll automatically sign you up for it. All right. But because it meets every day, goes at a fairly quick pace. Now, both. All right. Both of these classes go fast. It's just one meets every day, one meets every other day. That's the difference. But this one is not easier than that one. We cover twice as much material because we meet every day. But the homework in this one's just as hard as the homework in that one. All right. Now, if you have an 89 or above, I also recommend you for this one. So everybody that had an A got recommended for this one. But if you had an A, I also recommended you for this one. Okay? And I also recommended you for AP Stat. Now, the people who should take AP Stat are people who know that they're not going to do anything mathematical at all. Okay? And all you have to do for this one is everybody that had 85 or plus, I recommend you for that one. So if you've got 93 or above, you're recommended for all 3 of them. All right? If you've got 89 or above, you got recommended for 2 of them. And if you got like an 86 or an 87, just recommended you for that one. Because we have found that in the calculus class, you will do better in calculus if your average is a little bit over just a solid 85. Okay. I would really love to have a bunch of you take that course. I teach this one. Miss Jones teaches this one. But I know that there are certain ones of you who have, like, you'll have a class that's offered opposite that class. And it might be something like Act Two or something that's a single shot class, and therefore you don't get a chance to be in it. But if you can be in that class, if you get the through that class, you're ready to go into Calc 3, which is about as good as you can get going into college. It's the big advantage for that one. Yes, you do. All right. Now, but now, just like any other AP class, in some exams or some colleges will require you to have a 4 before they'll give you credit, or a 5. Peyton? Well, I'd say there's a good chance. At the semester this year, I have 12 people in the class, and 9 of them had A's. All right. Now, a lot of them are right at 93. Okay, and some of them are a bit higher, but a bunch of them are right at 93. But last year, in this class, 10 out of 16 people, 10 out of 16 made 5s on the exam. Okay, but it was an exceptionally good class. But this year's class is showing signs, like if you go by their midterms, we should have, out of 12, we have a good chance of having 9 out of 12 make a 5. It may or may not happen. You can't tell. All right. All right, you may go. You're welcome.